So 1.2, what we're looking at today. First of all, what are we learning today in 1.2? You can tell me. Terrence?
Multiple step equations.
Yeah, multi-step equations. How'd you know that, Terrence?
I read the board over there.
Right? Where else is it? Over there. The I can statement. It's also on Schoology in the update. Right? So you should know when you come into class the basics of what we're going to talk about that day. Right? You can just as you walk in, just look over there. Okay. All right. So we're doing multi-step equations. Multi meaning more than one step. Multi-step equations here. First one we're going to do. It's going to look like this. We're going 2.5x minus 13 equals 2. So last week we had one step where there was just one thing attached to the variable that we had to get rid of. Now we have more than one thing attached to that variable. And when I say attached to the variable, I mean on the same side as the variable. So we need to get rid of the 2.5 somehow, and we need to get rid of this minus 13 somehow. Two things we need to get rid of. So really the question becomes, which one are we going to get rid of first? First and action, which one do you think we're going to get rid of first?
Minus 13. Yeah. No, because you always start with unless you start with 2.5 probably to get it to be like x minus 13. Oh.
Okay, there you go. Raise your hand and tell me which one do you think we are going to get rid of first here? Maddie?
The 13.
The 13. We are going to get rid of that 13 first. Here's the reason why. Okay, we all know the order of operations, PEMDAS, right? We all know PEMDAS. That's the order of operations, the order in which we do things. That's when it's an expression. You're simplifying. You're going to do the parentheses, then the exponents, multiplication, division together, addition, subtraction together. When we go to solve an equation, we're trying to figure out what are we going to move, what are we going to get rid of first. We have to go backward through the order of operations. Go backward through the order of operations. So that means we are getting rid of all the addition and subtraction first. Then we can get rid of the multiplication or division. So we're going backward through that order of operations. That's going to tell us what we can get rid of first. Right? So we are getting rid of the minus 13. So I got minus 13. What's the opposite of minus 13? Yeah, so I'm going to add 13 to both sides, just like we did the other day. Cancel that out. I have 2.5x left over on the left. I got 15 now on the right with that 2 plus 13. So now I have 2.5x equals 15. We know that one step from Friday. We have multiplication. We divide. Anybody know what 15 divided by 2.5 is? Yeah. 6. And if we didn't know that, that's where we grab the calculator. We type in 15 divided by 2.5. Okay, not a problem. Yeah.
Are you allowed to use your calculator on the big ideas?
Yes. Yep. Yeah, just in general, we're going to be able to use a calculator. I don't want you using it on like 2 plus 13. You shouldn't need it, right? But stuff like this, sure. Go for it. All right, so we're going backward through that order of operations. All right. Seven. You got it. 7. Let's try it out. Let's do this one. All right, so that's all that. Work. Backward through the order of operations. Talk to somebody next to you, see if they got the same thing here. We got
So I'm going about
the same answer.
would you do divided? So would you do divided by negative 5? That's right. Yep. I was wrong. And then you'd get negative 5 or negative a half.
You can't forget about the negatives, but when you do it in like two
So
inside that box,
X
and
equals
four outside.
All right, here we go. Here we go. Raise your hand, tell me what's the first step? First step here. Luke. There you go. Subtract 10 both sides. Thank you. So we have negative 4x now is equal to 2. Our last step here. Yeah.
divide by 4, negative 4 on each side.
Good. Divide by negative 4 on both sides. Now, at this point, I'm going to stop us. Right? And I'm going to have you write down a sentence for me. All right? Very important. Get you write this down. If there's no decimals in the question, there's no decimals in the answer. If there's no decimals in the question, there's no decimals in the answer. What I mean by that is you should not give me a decimal for a solution here. If there's no decimals in the questions, there's no decimals in the answer. Which means we got to deal with fractions instead of decimals. Not hard, it's just what we got to do.
What I did was I just crossed off the negative 4s and I just circled the 2 over negative 4.
Yep, and we're going to simplify that, but you're absolutely right. That's the fractions right there. Okay. And we talked about that the other day, using fractions, right? As you show the work, the answer is there. But if there's no decimal in the question, there's no decimal in the answer. So yeah, we cancel out the negative 4s. We have 2 over negative 4, but you have to simplify that fraction. Okay, what is that simplified
Negative 1.
going to be? What was it?
Negative 1.
Negative 1/2. So negative 1/2, that's going to be our answer. So I shouldn't see a negative 0.5 there because there weren't decimals in the question. A negative 1/2. Take that sentence that you wrote, circle it, star it. Okay, that is important. Okay, that is important. Make sure that when you look back at your notes, you see that. All right, next one to try. Let's go. Eight minus x equals 12. Let's see what we can do. And show the work, follow the steps. The right way. Even if you're unsure, try something. The only way we learn is by trying. I will tell you that second hour when I did this, about 40% of the class made the same mistake. Made the same simple mistake. Curious as to how many of you made that mistake. Let's see. Raise your hand, tell me what's our first step here. What we're going to do. Ready? We are going to subtract 8. Brayden, why are we subtracting 8 if there's a minus sign here?
Because it's not like x minus 8, it's after it's 8 minus x, and you don't know what x is.
Yeah, that's a big difference between x minus 8 and 8 minus x. This is a positive 8 here, right? This is a positive 8 that I'm trying to get rid of. So if it's a positive 8, I got to subtract 8 to get rid of it. So make the change in your notes if you need to, right? It's okay if you make mistakes. Let's just not make them more than once. So you have that positive 8. Let's subtract 8 from both sides. What that does for us now is I don't just have x here, right? I've got negative x. That negative belongs to the x. So I now have negative x is equal to 4. We gotta be careful on that, okay? You got rid of that number in front, that subtraction sign is still there. So we need to bring it down with the x. So I got negative x is equal to 4.
Is that the answer?
That is not the answer because I don't care what negative x is, I care what x is.
You'd put a 1 in between the negative and the x, and then you'd add 1 to both sides.
So I like the 1 there, but we're not gonna add 1 to both sides. What we're gonna do instead? Yeah, you're gonna multiply or divide, either way, right?
Oh, negative 1x.
So that's negative 1x is negative 1 times x. So I'm gonna just say divide by negative, because that's gonna give me our answer, which is negative 4.
Wait.
Yeah.
So I didn't do that. I did so I saw the negative right away, and so then I did plus negative 8 and that ended up canceling that out. So, to start off, I did negative 8 plus x just to
So you changed it to negative 8 plus x?
yeah.
Well, that's changing the meaning of it though. Negative 8 plus x is the same thing as x minus 8. That's not the same thing as this. Right?
Yeah, but then I did plus negative 8 to cancel that out, and then I did.
But if you have this, you're not gonna add a negative 8, you're gonna add a positive 8. Right?
Yeah.
Because if you put another negative 8 there, that's not gonna cancel out.
I don't know what I did, but I somehow got negative x equals negative 4.
I think you might have gotten lucky. I think you probably made 2 mistakes and it canceled each other out. Luckily. Okay? And we can't rely on that. Okay? So we get rid of that. We've got that negative that comes down. We divide by the negative to get there. Okay?
I got the same answer, just had a completely different way. I did like everything above and then I just carried the negative down.
What do you mean you did everything above?
I did the subtract 8 and then I just got minus x and then I just thought it was x, for some reason I just thought it was x equals minus 4, negative 4.
Yeah, once you get here, right? You can just switch the signs. It's the same exact thing, right? That's all that dividing by negative 1 does, is switch the signs. So if you have negative x is equal to 4, positive x is negative. Yeah, we can do that right away.
And
For
is
sure.
that always true?
Yep, for sure. Because you're just switching the signs. And that's completely fine. It's the same thing as multiplying by negative 1 or dividing by negative. Yeah, go. So if it's negative x equals negative 4, positive x is
4.
positive 4. You just change the sign. Yep. Yep. Good. Anything else on that? That's good conversation. Okay. All right, moving on. So hopefully we learn from that. Hopefully we don't make that same mistake again later. The next type of problem that we're going to see. Negative 12 is equal to 9x minus 6x plus 15. Let's copy it down and then we'll talk about it. We've got 3 types of problems left. This is one of them. And I got 2 other types that I got to show. That we're prepared for the homework. All right, so we've got this. Before I start moving things, when I say moving things, I mean getting rid of them from the side of the x, right? Before I do any solving, what can I do? Fred? Perfect. Combine like terms. And remember, like terms are the ones that have the same variable. They've got the same variable. So our like terms here are 9x minus 6x. Those are the like terms. So I'm going to combine those together. What is 9x minus 6x? 3x. So I got 3x plus 15 is equal to negative 12. So whenever possible, we want to simplify by combining like terms, and then we can finish solving. I'll just go ahead and finish that. finish that problem. And solve that one, make sure. Hey, check somebody, so you've got the same thing?
Negative 9.
Sure.
No, wait, I got
Yeah. Just I got here and then it said that. And
Just say it's like,
negative 9 is
say your answer, discuss if you got a different.
wait, you're not finished with it? Then how do you know you got negative 9? Because I'm to here.
All right, here we go.
Negative 27. I had to use my calculator.
So we're at -9. Okay, remember, when we are discussing, the whole reason is to catch mistakes, right? So if you get something different than the person next to you, that's when you look at your work and you say, all right, what did you do? Where did we go different? And figure out who's right, who's wrong, if you can. Right? If you both got the same wrong answer, then well, right? And then that's what we go over.
You have to put the number before the. Could you put x equals negative 9?
Either way is fine. Yep, either way, it's the same thing.
So the guy thinks multiple on the fleet.
Big ideas is just gonna say x equals and then give you a space for it.
Oh, okay.
But on a quiz or test, doesn't.
You know.
Yeah, so we got -9. The biggest mistake I tend to see here, just people not being able to subtract numbers. Okay?
Plus negative.
-12, -15, however you want to think about it is
Plus
fine. I know I've got two negatives that are on the same team, right? So I'm just gonna add those together and keep it negative. I don't go with the change it to plus a negative. I just think of, I know they're both negative, right? I don't need to rewrite it for me to understand that. And so I can get that negative. Anyway, there you go. Any questions on that? All right, moving on. Yeah, two more types of questions we gotta see. Here's one of them. Copy it down. Okay, very quickly, the person next to you, tell them what is different about this one and what do you think we should do about it?
Parentheses. Pen is backwards. Yeah, I was about to say, would you do pen that's backwards? You know. Why do you always do pen that's backwards?
Yeah.
Ask like Alexander.
Okay, here we go.
Alexander.
Here we go. So of course, the parentheses are what's different. So raise your hand and tell me what we're gonna do about it. What should we do about it here? Okay. Yeah, we can distribute that too. Remember, distributing the 2 is when you are multiplying what's on the outside to everything that's on the inside. So we distribute that 2 to both of those. Right? I like to draw in the little arcs there, so I know I'm distributing, I'm multiplying. 2 times 1 is 2. 2 times x, or 2 times negative x is negative 2x. And then I still have that plus 3 equals negative 8. So we can absolutely do that first. We have to deal with those parentheses at some point. Okay, so we distribute. What should we do now before we still start solving? There,
Combine like terms.
combine like terms, right? We said like terms are the ones with the same variable, or the ones that don't have a variable are considered like terms. So we can combine the 2 and the 3 to get 5 minus 2x equals negative 8. Okay, so we can do that. That's getting it as simplified as possible before we start solving. Right? We distribute it, we combine like terms, then we can solve it. Let me show you real quick before I have you finish solving that. There are other ways that we can do this. The other way that we could do this is by going backward through the order of operations like we talked about before. And dealing with the parentheses last. We could do that. We could get rid of the addition first. We could subtract the 3 first. And get here. We could even get rid of the multiplication. And say, all right, well, this is times 2, let's divide by 2. We could do that. Or we could stop here and go, all right, now I'm going to distribute. Either way, okay, it doesn't matter. There's different ways to solve problems, as long as you're following the rules. Okay, so you're just going to find something that's comfortable for you and keep going. Since we all got here, we all have this in our notes. Go ahead and finish solving that, please. Finish solving that one. Careful that we're not making that mistake that we talked about earlier. Remember, no decimals in the question, no decimals in the answer. The answer should be a fraction.
Is that the same thing for big ideas?
We got it, it's going to show it on fractions all the time. They might accept decimals, but they're going to show in their answer key. They're going to show fractions. All right, let's take a look at it. Take time. We have a positive 5, so we subtract 5. All right, even though that's a minus. Positive 5, subtract 5. I bring down the negative with the 2x. So I've got negative 2x is equal to negative 13. I got multiplication here, so I'm going to divide by negative 2. Now, a negative divided by negative. What's a negative divided by negative? Positive. So I can cancel out those negatives, and I'm just left with 13 halves. And I'm going to tell you right now, improper fractions, completely fine. Okay, we don't need to change that to 6 1/2. It's right there in your work. You showed the work, you did it. We've got that 13/2. Let's leave it as 13/2. Okay, Big Ideas is going to do that. Big Ideas is going to accept that 13/2 and actually prefers it to 6 1/2.
Will they accept like 6 1/2?
Sometimes yes, but there was one today that it didn't accept the mixed number, but it did accept that. Okay, so just get in the habit of leaving it improper. Completely fine as that.
You just always do that thing, nickels, to always simplify.
Yep. So we're still going to simplify, right? We're going to simplify if it's like this. We're going to simplify it down here. But if it's improper, we can leave it as proper. Yep. So just change them up. Okay. All right, questions on that?
No.
Okay, last one. Last one. Then homework time. All right, so this one is different, right? This one looks different. Got a big fraction on the left side now. And we gotta be careful on this, okay? We still have 2 things to get rid of. We've got divided by 2, and we've got +4 that we need to get rid of. And what we've been saying the whole time is go backward through the order of operations. But I will tell you right now that we cannot get rid of that +4 right away. We cannot get rid of +4 because it's x plus 4, this entire thing divided by 2. It's not just 4 divided by 2. It's not just x divided by 2. It's this whole thing divided by 2. So what we need to do is we need to think of that as being in parentheses. So if you see a fraction like that, let's think about the top being in parentheses. Because now when we go backward through that order of operations, we're getting rid of the parentheses last, which means we're getting rid of that division first. Okay, so when you see this type of problem, we have to get rid of that denominator first. We have to, otherwise it's gonna be wrong. So I've got divided by 2, I'm gonna multiply both sides by 2. That gives me x plus 4 is equal to 24. Now it's a nice, easy one-step problem that I can solve. Okay, but if you don't get rid of that denominator first on this type of problem, it's going to be wrong. And we're gonna see a couple of those come over. So I just wanted to show you, explain it a little bit so that we do. Okay. Any questions here on 1.2?